Alrighty, long time no see. It's time for Bevy 0.13. So I'm probably like a week late on this. I saw Bevy 1.3 came out and was going like, oh sweet, I can record the video like the next day, and then things just kept getting in the way and just never had time when it was quiet. But I have been through the list. It doesn't have nearly as big a sweeping changes as some of the other Bevy versions, but definitely has some really good quality of life improvements that I was not expecting. But again, like nothing that I was like, man, I've been waiting for this feature. Just a lot of stuff that I was like, that's going to be really nice if I ever need it, or like it'll be really good for new people starting up Bevy that haven't had to deal with some of these experiences before. So a lot of it's like optimization based. So they talk about initial baking lighting, which is to do with the fact that you can like bake the lighting into the geometry when using Blender, and then have Bevy basically render it quicker because it's not actually rendering the lights. It's instead doing some kind of light map, pre-calculated, pre-computed global illumination. And I think this is just going more on technical, like how it's using voxels and calculating all the illumination. A lot of this stuff, like I don't understand, and I've read like a while ago, and so I'm just gonna skip through a lot of the stuff that I don't know that I can add a lot to. So there's also like the minimal reflection probes, and so this is about allowing like skyboxes, but on objects that aren't the sky. So this world can have a skybox, and then this cube here or the sphere can have a different like skybox 2D texture thing that they use to render skyboxes. And this is just all about allowing to have multiple of those in a scene as opposed to just having the one skybox. Uh, so this has got some specular occlusion is added. It's approximate indirect specular occlusion, and that's to do with lighting around corners. So if you look with the specular occlusion on, all the like sort of corners are lit sort of nice and evenly. It sort of doesn't have sharp corners. Whereas if you turn it off, you can see like in here, the sun's coming in this way and directly lighting it. Whereas here, it's like the sun's not directly lighting it because everything else is sort of lighting it a little bit. So it's not as sharp a contrast between the 2 points. Bevy's added a whole bunch of additional primitive shapes. So I remember that they had things like a plane and the cubes and squares and stuff, but it seems like they've added just a hell of a lot more. Like there's cubes, toruses, and they all have meshing functions. So you can do like the geometry and stuff like this, and like make a lot of primitive stuff that you otherwise would have had to have made in Blender and then imported across. I've said capitals before, stuff like that. For 3D games, I used a lot of them, but they've added more detail and I think more customization to it. Again, I haven't read through a lot of this stuff. Like today, I read through a lot of the later stuff. Anyway, I've broken my computer, so I can't edit a lot of this stuff out because my editing software tells me that I no longer have a license key for it because I've installed it through Steam and then changed computers, and so it doesn't recognize my computer. So you have to apologize for my non professionalist in the fact that I'm just not going to edit this video. I'm trying to get through it in a sense that won't result in me needing to edit anything. So one of the things that they've changed that's going to be really useful to people like, but not me, is that they've added system stepping. And so this is the idea that when you're in debug mode, you can step through and like run one system at a time while keeping your rendering continuing to run. So I guess that must mean you can specify like what systems are rendering systems and what systems are actually game logic systems. But the idea being that when you're in like a debug trying to find a very specific bug, you can go system by system and find out what system the bug actually occurs in, and do like how Unity has it, where when you go into a game, you can click the pause and all the logic stops, and then you can click like step one frame at a time, and Bevy breaks that down to the next level of allowing you to step one frame, continue a frame, or you can like step a specific system rather than having to actually like do it frame by frame. You can actually go down to specific system level. By looking at this, you can seem to be able to like skip through. Like you can always run this system, or you can stop on this system when it runs. So you could use your system conditions or your run conditions to actually have breakpoints set, and then there's always stop on a system. So yeah, there's disabling systems during stepping, so you can make like never run a system while you're in stepping mode, and exclusive systems for stepping. So that would be systems that only run while you're in stepping mode. So you could have it like I guess pause one frame rate calculator and display a different frame rate calculator when you're doing stepping mode to allow you to have an accurate representation. The brain catch up. So I was so spaced out of it. So systems that rely on events apparently won't work, and conditional systems may not run because obviously when you're in the stepping, the condition may not have been met like that frame, and therefore it won't actually run, whereas it may have been met that frame if it was running the frames continuously. Like I guess like 2 or 3 frame lag between things can cause them not to run. Cameras have more control, so you can actually change the exposure of the camera. So you have a scene that's lit really well, and then a scene that's really dark with the same like lighting and everything. You've just changed the exposure on the camera. This can result in like a more real world camera sort of thing where you can actually dynamically control the camera, make things like underground environments much more atmospheric, because rather than making them darker to try and make them more atmospheric, you can change the f-stop and the exposure so that they get like sort of more flat lighting or less flat lighting, like the shadows are darker but the bright spots are brighter kind of experience using the sort of effects that you can do in a real life camera. UI camera drawing, this is the first thing that I kind of went like, I don't really understand what's going on, like why this is such a big thing, but they're saying that your UI can now be targeted to specific cameras, which allows you to do things like split screen, where the UI is rendered on the left camera and on the right camera. The main thing I don't get about this is I would think that you would need individual logic for the buttons, depending on if it was on the left screen or the right screen, so you would need to place them on the left and right anyway. But I guess if you're using like the Flexbox style of things, it means that you can say put it all the way to the left and it'll be all the left of the left camera, not of that specific camera, so allowing for UI to be placed sort of on the split screen rather than you having to remember that the split screen's only half the screen. So because it removes the layer, because instead of doing like 2 boxes representing the 2 screens, you actually have the camera view itself being the representation. But again, this change didn't make any sense to me, because I would have thought the UI would require either custom logic already to be able to function on the 2 different screens, or be not too hard to place things to make a split screen. But maybe I missed something when I was reading through this. This is something that I can't wait for the next Bevy jam to get to use, and that's the texture slicing. So there's a thing called 9 slice, which is where you break up a base texture like this into 9 segments. So the corners, the straights, and the middle is your 9 segments, so 3x3 grid. And then you can then scale those segments independently. So this is how Bevy used to scale it, where it would just stretch the image to fit the space, whereas this one is a slice scale, so the corners don't get scaled at all. The middle section here doesn't get scaled, but these side sections are scaled on the axes so that they can reach the top and the bottom, and the middle section is scaled to fill. So it lets you do things like button borders, where if you were just to scale this, it would mean that you'd end up with thicker and thicker lines, whereas because the 9 slice basically has a section in the middle that has no texture to it, you can scale it indefinitely and your lines will all stay the same size, because you're only scaling them on dimensions where they can be scaled without like warping the image. You can also apparently do tiling. Yeah, cool stuff. I don't know. Here's another thing that, like, again, I am too stupid to understand, but like I can see this being incredibly powerful for people wanting to make scripting languages and stuff, is dynamic queries. So originally in Bevy, you had to specify the query at compile time, and the compile checker would take care of everything. But this meant that it was impossible to get user input to check queries unless you wanted to know like specifically every possibility that the user would want to query, and have those queries set up and running that you only like sort of run the system or access that specific query when the user queries it. You couldn't dynamically at runtime generate queries that the user could input. So that means that if the user created something like a scriptable object sort of thing, that you couldn't access it because there's no way you could have written compiled queries for something that was created at runtime. And that's no longer the case. So you can still use all your normal queries, but there is now a query builder that allows you to sort of specify based on type IDs, which you can then use the type registry to look up what the user's actually typed in to get the name and type ID, and then you can build a query at runtime that then can query the world and access all those stuff. So that's going to be awesome for like scripting languages and making like moddable games, because you will no longer need to compile specifically for a certain filter or a certain component when making your queries, and instead they can sort of write scripts that then look it up. So hopefully this will mean making some pretty incredible plugins that allow for like JSON describing or RON describing behavior that is loaded into the game without needing to recompile. There's also query transmutations. This is something that I would have loved to have had back when I was actively working in Bevy and didn't have a full-time job taking me away from it, is the ability to have a query that sort of like gets all the entities you need, and then having like reusable subsections of code that say only take a query with a transform. In the old version of Bevy, you would have to have a query that specifically was querying for transforms and pass that down. But now you could actually query for like all transforms and velocities and then pass that to a different system that you can transmute it into one that only has transforms. So it allows you to have more reusable bits of code and simplified code, because you can transform queries into different shapes. It does state that one of the drawbacks is you will only get the results of this query. So if you're querying for transform and velocity and then transmute it into a transform version, it will still only show you transforms that have a velocity. In my opinion, this is actually a benefit more than a drawback, because it means that you can basically apply filters, that you can access the data of the filter at a higher level, and then when you drop it down a level, it just becomes a filter. And like, again, like it means that like this system here is doing a query for transform and has no idea the queries, like what filters are applied to the query. It just knows that it's got access to some number of transforms in the world, whereas, you know, on this level, you do know that there is velocities attached to them, so you can reuse code. And this could hopefully allow for people to make like utility plugins that have a bunch of functionality for like physics engines that you can then like implement the smaller subsections to build up a larger system rather than having to specifically tailor everything. And one of the things they're saying is the most useful place is to remove mute, so you can basically access it mutably and then drop out, remove the mutability, and then give it to something else that you know may not necessarily want to mutate things, and gives you more type safety, that kind of thing. They've split while queries. So this is something that I find interesting, because in my head I thought they were already split, which tells me that they probably had them split, merged them, and they're splitting them back apart again as things have changed over the years that Bevy has been out. So this means that certain things like the filters of a query will no longer be able to be put in the main data section of the query. So this was one of those, as they say somewhere in here, about foot gun that for new users, and I've definitely done it myself a few times, where you would put the parentheses in the wrong spot like this, and you would say entity with component A instead of entity comma component A, comma with component A, like without the parentheses. And therefore, as it says, like this is, you could do this before Bevy 0.13, but you can't now. They've removed this because this is incorrect, because it just made things clunkier, and it would result in like, you know, having issues being like, well, why is my types all wrong, or that kind of thing, because you've actually put the parentheses in the wrong spot. Now you have to have it like this, where you've got your entity and then your width. Your filters have to be separate. It does state that the only things is like, so the main reason for changing it is that changed and added would have actual negative side effects when doing this, whereas all the others would just turn into a unit type and just clutter the environment, but they wouldn't actually have any negative effects. Another thing is an automatic implementation of the apply deferred. So apply deferred is the system that runs, that adds commands between systems. So if you want a system to be able to see what another system's done through commands, you have to have an applied deferred between them. And what Bevy does is it will now search through all your systems. If you order them, so you've specifically said this system and this system are ordered, it will apply an automatic applied deferred in the middle, rather than having to insert it yourself, because Bevy's basically saying if you say that the system has to run after that system, it's because you want to know that there's a difference. And the reason that you want to let Bevy do this is because Bevy will automatically combine them. So like this one, where the two systems, or the four systems have the two chain dependencies, but because there's no cross dependencies, there will only be one applied deferred inserted between, because 1 and 3 can run together, then applied deferred can run, and then 2 and 4 can run together. So that's all very good about like personally, I don't think it was necessarily the right direction to go, but they do say that there are several ways of opting out. So hopefully, like you can opt out at different levels of it. But the main reason I would think it's bad is because it's going to result in if they've got their heuristic wrong for determining where to put it, it may just be putting these all over the place when it's in reality I'm chaining them together not because I want them to run after each other, but because they're modifying something else. But it does say only when they access commands. But it's kind of that thing of like I'm hoping that there are good ways of stopping it from being able to insert it when you like, I want the commands for something else, not because of the ordering of the systems. More flexible one-shots. So one-shots were introduced in 0.12 and they were something that was so phenomenal. Like it was something I was going to make a video on and then I just ran out of time and just couldn't. But one-shots are like systems that you can run like without having to put them into the scheduler. So you don't have to let the scheduler decide when they're going to run. You literally just say, okay, this system, like when you register it, I think it's down here. So you register a system and you get an ID and then you can go like any other point in your code where you have access to the world. You can be like, run this system right now. Like, I don't care what, like, it doesn't have running, you can just run it now. There was also like one-shot systems where like what is it? So you can like run the system there and then without this ID, like, but it meant that you didn't have any track state, so you couldn't keep track of local variables and stuff like that. But it did mean that you could just say like run this system once, like you could then like use closures and stuff like that that would only be run that for that one time and not saved any state between. So that was it's a really cool system. Like would mean that like card games and stuff, you could have like when this card is played, run these systems, and then you could have like card effects and stuff all be like, hey, this card's been played, run this, run this, run this, run this, rather than having to come up with some kind of like run conditions and stuff like that that trigger when the card is played. Instead, it's like, hey, this card's been played. Now I'm going to run these systems that will do the effects of that card, like changing score and stuff like that, without needing to necessarily have like events and things trigger that. So I'm imagining things like Slay the Spire, and that would be much more easy to program with one-shot commands, one-shot systems that, you know, when a specific effect is triggered, rather than as a trying to work everything out as events and run conditions. They've also made it so that exclusive systems can be one-shots, as before you could only have very specific systems. And they've also made it so that you can pass data in and out of one-shots, which is kind of the thing that was like really the limitation of one-shots, like where it was like they could be improved, and obviously they've done it, is that the one shot would be really useful for like extracting data from a world without necessarily having to query for all the stuff and changes that may happen. Instead, you could go, hey, run this system, and that system will pass back a number, and that, like, you know, and then I'll continue running my system with that number. So you could do like way better results of like, it's, I guess technically like queries that would also modify the world, that kind of thing, like queries with side effects, I guess. I don't know. But yeah, it's a really cool one-shot systems. I'll hopefully get the video done at some point. I should hopefully have more time next week, so I will probably be doing like live streams, like updating the Minecraft clone to 1.13 and some of my other projects, I guess, to 0.13, just because one shot, because I'll have time to be able to do live streams and stuff. So what else has they changed? So they updated to WGPU 0.19, which just comes with some nice performance improvements. Again, it's another one of those not directly going to affect me, but it'll be nice just having that. It was 10 to 15% increase in frame rate. Like that's just, Bevy is getting faster and faster with every update, and it's just insane because it was already so fast. So they've you can I'm starting to lose the plot here. It's what happens when you talk for 20 minutes straight. So they've got the unload assets from RAM. So basically, the way Bevy worked in previous versions is that you would use your asset loader to load assets into memory, and then Bevy would send that memory to the GPU and do all its rendering, but wouldn't necessarily unload them from the RAM. It would still be on the CPU. So if you had so many gigabytes of textures and stuff loaded up onto the GPU, they would still be on the CPU, and therefore you couldn't be using that memory for something else. So now Bevy has the ability to specify like if certain bits of memory get unloaded once they've been sent to the GPU, so you don't have to keep constantly like using up memory that you may not want to be using up. They've also changed their batching algorithm. So originally they said that it used screen distance. So it would like use the distance from the screen, order everything in that order, and then check to see if two things had the same mesh and render them at the same time if they did. Now they've instead sorting by what material it uses and then checking to see if it has the same mesh. So basically, if it has the same material and then also the same mesh, they will be batch rendered together. And this apparently is rendered like up to 50% frame increase, or like I guess double-digit percentage increases. So that's a pretty good FPS improvement, especially for things like my hexagon maps and stuff, where I was originally trying instanced loading of maps, and I decided it wasn't going to work because Bevy was just so slow when you had like 100,000 entities all rendering at once. But by all these performance improvements, like if it's double digit, like even if it's only 10%, you're talking about like such an insane increase in frame rate, especially on top of the other like one or two, if it's 10% there and 10% here, like you're going from it was originally dropping down at 100,000 entities to maybe it's going to drop down at 200,000 or a million entities. So instanced maps are probably going to become something that like I may actually try again, just because of the number of improvements that have happened. Because I think I started that in 0.9, so there's been a lot of improvements since I tried instanced maps, and it's hopefully going to continue to get improvements on every single update. Animation interpolation also got two new methods, so you can instead do stepped, linear, and curve based. So basically, instead of so linear being that you between your two keyframes, it just moves in a straight line, like equal distance each frame, as a percentage of time. The stepped means that only when it gets to the keyframe will it suddenly become that new state. And then there's the curve, which means that basically it starts off slow, gets faster, and then slows down before it gets to the other end. So it does a bounce sort of thing. So you can see this one's taking and it's just moving at constant speed, whereas this one starts behind, overtakes, and then they both finish at the same time. So it's pretty cool that Bevy now lets you do animation curves and stuff like that. I believe they added all the curves and stuff in the previous version, but I don't think it was necessarily something you could set up. Like, especially, I don't think it had the stop motion sort of effect. So there's also an animation trait, which is where you can apply this to, say, like your custom component, and then it allows for people using your crate to animate your component by specifying, an interpolate function and a blend function, which will allow for people to not necessarily know how your code works, but be able to interpolate between your components or blend your components together. And also, obviously, this is going to be used in Bevy for like transforms, where you can take one transform, another transform, and you can interpolate between them or blend them together without necessarily having to know all that code yourself. Whereas at previous versions of Bevy, you would actually have to know how to make, let's say, distances interpolate or scales interpolate between each other. Instead, Bevy can now implement that code, or someone making like a physics engine or a rendering engine can do all that for you. So this is another cool thing. So it's extensionless asset support. So basically, in previous versions of Bevy, for those that didn't know, is you needed to use the file extension to tell Bevy what asset loader to use. But I believe in 0.12 they added a metadata file, and this allowed for Bevy, like for the user to specify what asset loader to use for a specific asset. This meant that you could load multiple assets from the same file, but also you could then sort of say, hey, this thing is a sprite sheet, whereas this one's just a single sprite, and they could both be PNGs without needing to like come up with a PNG dot sheet or something, because of like needing to tell the asset loader that it's actually a sprite sheet. So the extensionless one works now by allowing you to specify, when you're loading it, the asset type. And so usually this is inferred by the handle. So the example here is the audio and loading an audio source, and the graphics and loading a graphics settings. So, and then down here it's saying like what you'd get is a handle to an asset settings, because you're loading an asset settings. And the way it works is the .meta file will first specify what asset, because obviously Bevy allows you to have handles of a type that aren't necessarily related to the actual underlying data. And then if there's no specified in the meta file, it will use the handle type. And if that doesn't work, it'll fall back to using the file extension. The big advantage of this is it also means that you no longer need to specify file extensions when you're making an asset loader. If you don't obviously specify them, then it won't be able to infer them if like the user doesn't specify, but it does mean that this is no longer a required part of the asset loader, whereas before you had to try and come up with unique asset file extensions. It's the other thing that they talk about in the big thing was it also means that you can now do extensionless asset loading. So you no longer need to have the asset file and extension line up because you can specify that, you know, say like bang here is loaded from the same folder as blob because the blob is just the raw data that is then sent over network. And then you can also load the auto file again because it's still technically loaded. So it's all going to work really nice for allowing like more intro plugins for that can like load assets, and you could say have image processing assets where it's like you load a PNG and it's no longer requiring that the PNG be it like you don't have to change the file extension to get the PNG to load with the specific loader. You can actually load a asset and give it a PNG and it'll convert the PNG into the correct asset type. So they've reworked texture atlases because originally Bevy had a whole bunch of like specific sprites and things that were related to texture atlases. Now they've condensed all those back into a singular texture atlas and sprite like components when related to UI and textures, but have instead made it so that if you attach a handle texture atlas, you will get access to all the information that's required. So you attach the texture atlas component and then also a handle to the texture atlas layout, and it contains like a usize, I guess. So that means that basically they've combined all the duplicate information that was originally in a texture atlas sprite and a texture sprite, and instead made the texture sprite the only bundle, and the texture atlas contains all the additional information instead of being its own complete package, I guess, or bundle as it's called in Bevy. So what's next? Light rendering layers. This is about allowing things to be like switched on and off, I think, on layers. It allows you to quickly hide and show entities by filtering what a camera can see. So I guess the example here is using mirrors. So you can allow things like vampires not to show up in mirrors. You can tell I'm getting really goddamn tired. I can't even read at the moment. Bind group layout entities. Is again another something I don't quite get. I think it's related to shaders where it's like they've changed how shaders can be bound together. They've just changed the UI layout. The much more fun one is the type labels for render graphs. So originally, before 0.3, you had to actually specify a name, which was prone to typos. Now it actually uses the type system to derive the names, which not only makes the names shorter, because instead of having to go core graph name, you can just say core 3D. Like instead of core 3D, like the type itself encodes the name of the type, which also doubles up with your uniqueness, because you can't have two packages with the same name, which means that all of this stuff will like all the paths will be unique, and therefore you don't have to worry about your name that you picked conflicting with someone else's rendering. They updated WinIt, which is the windowing program. So the main big change, because of the idea of WinIt is that you can run the same code on multiple operating systems and you should get the same result. It's like the windowing code, but they did change key codes from being logical to positional, which means that instead of it being I pressed the Q key and it doesn't matter where you've bound your Q key to, your Q key is your Q key. Instead, the key codes are I'm pressing the key on the top left corner as opposed to the Q key. And they're saying you have to use received character events if you want to get the behavior of you actually pressed the letter Q as opposed to you've pressed the key that would be letter Q on QWERTY. The idea being that if you set up WASD as your movement keys, when someone that doesn't have QWERTY as their keyboard starts using, they'll still have the same physical keys mapped, but the letters will be different. So it's sort of they've decided that's a better approach than to do it the way that it originally was. It shouldn't really matter to most people. But one example I could think of is the game template that I did, Froxies or something. I don't remember what it was called, but I did a video on a like a game template, and when I was doing the video, I found out that the E key that would open the text also opened the editor, and when I put a pull request or like submitted an issue, the developer said, "Oh, it's because he uses key codes, or no, like scan codes instead of key codes, which means that because his keyboard wasn't QWERTY, the E key was physically somewhere else on his keyboard, and so to him pressing the E key and the interact key or the UI binding the editor open editor were actually two separate keys, whereas on a QWERTY keyboard they were the same key." Anyway, so they've now added multiple Gizmo configurations. So Gizmos are what they call instant mode, which means, or immediate mode. So unlike meshes where you instantiate them and the mesh is rendered every frame, if you don't tell it to render the Gizmo, it won't render the next frame. Like they're only for that frame. And I think they're all drawn in order of their things, so they're drawn on top of each other. Like if you draw a line and then draw another line, the second line will be on top. There's no distance specified sort of thing. But so what they've done is there used to be a global config, and there still is, but they've now made it so it's possible for you to specify a sort of local config, so you can allow for your plugin to have a different Gizmo configuration to other plugins. And so it allows for like customization of your Gizmos without interfering with other plugins or having a plugin like adding a dependency and having that fuck with all your Gizmos because it changes things. They've implemented GLTF extensions. So now when you load a GLTF file, it's possible to tell Bevy to save the actual file itself as part of the asset, so that if you want to pass through it and find specific information that is related to an extension, so maybe some optimization mesh related things or some physics based information that isn't part of the GLTF standard but is instead an extension on top of the standard, you can now pass the file yourself when you're looking at information, rather than how Bevy did it originally, which was to pass the file, save all the information that Bevy knew how to use and discard everything else. Instead, Bevy will now keep track of all the information so that you can pass it yourself later. So now we're looping back around to asset transformers. So like I was saying, with the extensionless assets, one of the things that allows you to do is make asset loaders that will load an asset like a PNG, and you can specify how you want that asset to be transformed and what asset type you actually want it to be transformed into. And instead that it's a PNG is just sort of the starting point where it knows what asset it was trying to load, like the actual file type, and then it will convert it into the asset that you've told it to load. So the way this works is that they originally had an asset reader, which would turn the bytes into an asset, and then an asset loader that would convert those bytes into the physical asset inside of Bevy. And then there's an asset saver that would convert it back to bytes, and then an asset writer that could save that to the file system. Now there's also a transformer that can go in the middle that can convert one asset type to a different asset type, or make like modifications to an asset in such a way. So this will hopefully allow for like much more flexible asset loading and saving and stuff like that, so that you can allow for things that otherwise wouldn't have been possible, since you would have to save the file and then reload it as a different asset. Now you can transform them without actually saving it to disk. There's also all these entity optimizations. So they've made hashing entities much faster. They've also made option entity the same number of bits as entity by basically, I guess, saying if the entity is all zeros, it's none, as this optimization's been in Rust for a long time when it comes to you can use types called non-zero integers, and they've just added that for entities. So now they're basically non-zero entities as well. They've updated query for each so that you can now, instead of having to use the for each and the for each mute, you can instead use it like a normal iterator where you just iter mute and then for each and pass in your function. This has some optimizations, but is more about making it more idiomatic to use these functions than it is about actually optimizing these functions using the compiler. They've removed a bunch of table and row casts just to make Rust safer and like the actual underlying code easy to edit without breaking things. There's also that events now live longer. So apparently in the bug patch of 12.1, they changed it so that events wouldn't get cleared after every frame, because this meant that fixed updates necessarily wouldn't get all events, but this meant that now updates would get events that would be more than one frame old, because I think it was cleared like every fixed update rather than every update. So they've now changed this so that you can revert back to that previous type, and they're saying they probably shouldn't have put it in the first place. And that brings us to the end of the 0.13 updates, and just some of the quick things is that they're hoping to implement more editor, or like actually add the editor hopefully in the future. They keep saying that every update, but they actually look like they're making progress. Like they've got some sample photos, and they're also hoping to add some dev tools, a new scene format, which is going to be interesting, UI improvements as always, and meshlet rendering. So hopefully that will all get added, and I will see you in the next video, or in a live stream that I will hopefully get time to do. Sorry for the unprofessionalness of this video, but again, I don't have editing software at the moment, so I can't really fix any of the mistakes. Don't forget to like, comment, subscribe, and I will see you in the next one.